Here's a map of ancient Egypt. I've inserted 2 sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows of different lengths. For the observed difference in these shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment.